Okay, moving on to part 3, normal distribution table with any normal variable, not just z. Z is specifically the standard normal distribution, which is what's shown on the table, whereas if you have a different mean and standard deviation, it's not the standard z, and we don't just look it up directly on the table. We have to convert it to z first. Couple reminders. Reminder number 1, the table shows they are to the left of z only. Reminder number 2, what standard normal stands for. When people say word like standard normal, the word standard tells you that the mean is equal to 0 and the standard deviation is equal to 1. Whereas real life normal distributions have, any old mean and any old standard deviation. So for example, a common statistics problem is to work with IQ scores, and IQ scores are said to be approximately normal with a mean of 100 and standard deviation of 15. So if we're given a problem with this kind of situation, it's when you compare it with the table, it's basically quote unquote the raw mean, right? And raw standard deviation, because the table says mean of 0, standard deviation of 1, and the problem says mean of 100 and standard deviation of 15. How do we relate them? Well, we talked about this before. Remember this diagram, it says if you start with any normal distribution and we take the z-score of it, you end up with the standard normal with mean of 0 and standard deviation of 1. And if you want to go back, then you use the backward formula, the x equals formula, which comes out a definition of z. Z is how many standard deviations you are from the mean. So if you compute the z-score using z equals x minus mean over standard deviation, you get to standard normal to z. And from z, if necessary, you use the other formula to go back to x. Okay, so that's what we call standardizing. Okay, if you're given an x and you need the z, you standardize by using the z formula. And if some problem where you solve for z and then you need to get back to x, for example, you figure out z and you want to know what the IQ score is, then you go backward, either by solving this equation for x because you have a numerical value for z, you solve x algebraically, or you use the other formula, the formula that says z is the number of standard deviations from the mean. Then you take mean plus how many standard deviations from it, you get x. Right, so let's take an example. IQ scores are normally approximately normal with a mean of 100 and standard deviation of 15. What is the probability a person has IQ higher than 110? So what's the first thing we do when we have a normal problem? The first thing we do is to always draw the normal graph and mark up the diagram, right? So we have our IQ graph here. It has a mean of 100, standard deviation of 15. We don't need to mark it anywhere, just write it down here, I guess. What's the probability a person has IQ higher than 110? So you find 110 somewhere. It doesn't have to be exact. It's just approximately 110 is somewhere around here, maybe. Okay. And we look for IQ being greater than that. Okay. So the probability is the area, and this is what we're being asked for. So look what I did. I made it very clear that the information I know is on the axis. The known information of 110 is on the axis. You know what that means in terms of looking up in the table? That means I'm going to look up on the edge of the table, okay? And the thing I'm looking for is the question mark, which is in the area, okay? So now I'm gonna need the z-score. Z is equal to x minus mean divided by standard deviation, okay? Mean is 100, standard deviation is 15, and x is the given variable value, and it's 110, okay? So 110 minus 100 is 10 divided by 15, which is 2/3, so it's around 0.67. I only need 2 decimal in this case because the table only gives me 2 decimals. So, right now, note that there's no z on this diagram, right? But z takes the place of 110. So this says z is equal to 0.67. So z is the number on the edge. So I'm still going to find the number on the edge and look up what the area is, okay? So this 0.67 is the known information. It came from the 110, and that 0.67 ought to be on the edge. So z is equal to 0.67, 0.67, and that gets me this probability, this area. Okay, so the probability is 0.7486. All right, next example. IQ scores are approximately normal with a mean of 100 and standard deviation of 15. Find the cutoff for the top 2% of top 2% highest IQ. Again, first thing to do is to draw a diagram. Here's the axis, the IQ score. The high IQ scores are on the right. Okay, so I'm looking for the rightmost 0.02, the rightmost 2%. So because it's a 2% is the chance of someone being this high is 2%. So it's the area. So the known information is in the area, and I need to know that question mark. Right, now I could go look things up in the table, but there's one more step to do, and that is the table gives the area to the left. The table gives the area to the left, so I need to figure out what the area is to the left. If it's 0.02 to the right, then it's 0.98 to the left. Okay, 98% plus 2% makes 100%. Right? So that means actually I'm going to look up the number 0.98 in the body. Okay, I'm going to find the number 0.98 in the body, and then I'll see what the z value is equal to. So yeah, I'm not looking up 0.98 on the edge. Okay. I'm going to look for 0.98 in the body. Okay, the 0.98, the 98% is in the body. And it looks like it's here. It looks like it's closer to that number. So the answer is z is equal to 2.05. Z is equal to 2.05. So if I go back to my previous diagram, then I know that this cutoff here has a z of 2.05. Okay, but that's not the question. The question doesn't ask for z. The question asks for the IQ score. So I have to go from z to the IQ score. So I work backward from there. And the way I like to do it is x is equal to, z is 2.05 standard deviations. 2.05 standard deviations from the mean. So x is the mean plus 2.05 standard deviation. Okay, 2.05 standard deviation from the mean. So I multiplied this out. 2.05 times 15 is 30.75. So it's 100 plus 30.75, so it's 130.75. Okay. All right, so that's how it works. Okay, when you're not given, excuse me, you're not being asked questions about the standard normal, sorry, just convert it to a standard normal problem, convert it to a z problem, and then deal with it after. Okay, so sometimes you have to convert it to z at the beginning, you get the probability, and actually sometimes that's it, you're done. Okay? Whereas vice versa, if you're given a probability, you find the z, and in order to actually answer the question, you have to go from the z to the x problem. Okay. All right, so that's the end of part 3 and the end of the lesson. Bye.